Students, our next topic is equipotential surfaces. An equipotential surface is that surface at every point of which electrostatic potential is same. For example, if this surface is equipotential surface, then every point of this surface electrostatic potential is same. By definition, we know that potential difference between 2 points B and A, this is equal to work done in carrying unit positive charge from A to B. Potential difference between B and A is equal to work done in carrying unit positive charge from A to B. If A and B lies on a equipotential surface, if A and B lies on an equipotential surface, then potential at B is equal to potential at A. Therefore VB minus VA 0 हो जाएगा, WAB is equal to 0. Therefore this means no work is done in moving a test charge from one point to another on an equipotential surface. This means no work is done in moving a test charge from one point to another on an equipotential surface. equipotential surface पे एक पॉइंट से दूसरे पॉइंट तक, एक पॉइंट से किसी दूसरे पॉइंट तक चार्ज को ले जाने में कोई वर्क डन करना नहीं पड़ता. Therefore no work is done in moving a test charge from one point to another on an equipotential surface. If dl is the small distance through which a unit positive charge is moved on an equipotential surface, then small amount of work done in moving it. If dl is the small distance through which unit positive charge is moved on an equipotential surface, then small amount of work done होता है भाई F dot S, force into displacement. Force on a unit positive charge is E, displacement is dl. We can write it as E dl cos theta. Theta is the angle between E vector and dl vector. As we know that work done in moving a test charge from one point to another on an equipotential surface is 0, as we have proved it. Therefore this will be 0. As E is not equal to 0 and dl is not equal to 0, therefore cos theta is 0. This means theta is 90 because cos 90 is 0. This means angle between E vector and dl vector is 90. Therefore electric field intensity, this means electric field intensity is always normal means perpendicular, normal to an equipotential surface. Therefore electric field intensity is always perpendicular to an equipotential surface. For any charge configuration, equipotential surface through a point is normal to electric field intensity at that point. This means angle between equipotential surface and electric field intensity is 90 degree. We know that for a single charge, electric potential is given by Q upon 4 pi epsilon naught R. This means Q is the charge, 4 pi epsilon naught, these are constant. If R is constant, then V is constant. If R is constant, then V is constant. R is the distance of the point from the point charge. अगर R constant है तो electrostatic potential constant है. This means equipotential surfaces for a single point charge, they are concentric spheres. concentric spherical surfaces centered at the charge. For a single charge V is equal to Q upon 4 pi epsilon naught r. यहाँ पर Q चार्ज है वो कांस्टेंट है, 4 है वो भी कांस्टेंट है, पाई भी कांस्टेंट है, एप्सिलॉन नॉट इज द absolute electrical permittivity of free space वो भी कांस्टेंट है. This means if R is constant then V is constant. This means at equal distances from the point charge electrostatic potential is same. Therefore equipotential surfaces due to single charge they are concentric spherical surfaces. Therefore equipotential surfaces for a single point charge they are concentric spherical surfaces centered at the charge. उन सभी का सेंटर चार्ज के ऊपर होता है. For a uniform electric field along x-axis, equipotential surfaces are normal to x-axis. Equipotential surfaces are normal to x-axis. That is, they are the planes which are normal to x-axis or they are parallel to yz plane, या वो yz plane के parallel होते हैं. ऐसे ही equipotential surfaces for a electric dipole they are of the shape this. Equipotential surface ऐसे होंगे. These are the equipotential surfaces for an electric dipole. For a pair of equal and opposite charges, equipotential surfaces are these are the equipotential surfaces for a pair of equal and opposite point charges.